Thank you for that introduction, Tracy. So as Tracy said, I work for PIRSA and my background is in livestock, so I'll bring a little bit of that flavour to my presentation today. But I thought I would just start off with doing a bit of general information. So this graph here shows what South Australia's reportable emissions are. So this goes into our reporting into the Paris Agreement. And as we can see, agriculture accounts for 23% of our total emissions. So that's non-transport agriculture. So that doesn't include any transport that is associated within agriculture. So I think that just shows that, we have a lot of opportunities here to start looking at emissions reductions. And if we break that down a little bit, we can see, so this first column here shows our 2020 emissions, which is our most recent complete data set, which shows that enteric fermentation accounts for about 63% of those total agricultural emissions. So enteric fermentation is methane that is burped out by sheep and cattle, basically. The next biggest category is agricultural soils. So I think I'll explain a little bit later. I've got a picture coming up that shows the carbon cycle. So we will iterate that it is very much a carbon cycle. So it is quite natural for soils to both store carbon and then to emit it. But emissions relating to agricultural soils are largely things like excess nitrogen runoff, erosion and waterlogging. And then the next biggest category is manure management. So that again relates back to livestock. So just in terms of our state targets, we've got the two targets which sort of relates to what Adrian was saying just before. So our first target is to achieve 50% below 2005 levels by 2030. And our second target is to achieve net zero by 2050. So this graph here just shows that net zero is not necessarily no carbon emitted. It is a combination of reduced carbon emissions in alignment with stored or sequestered carbon. So what Adrian was talking about, any carbon that is stored in either soils or vegetation can offset the remaining emissions. So to achieve carbon neutrality by 2050, at some point along your right of that graph, those two dotted lines have to meet. And that will be a combination of emissions reductions and sequestration. And where on that graph that happens, we'll see. And to reiterate one of Adrian's points is that we need to be really looking at reducing those emissions as much as we can, and then relying on offsets or insets just to negate those really hard to reduce emissions, but our focus is on reducing those emissions. Which sort of brings me to the definition of carbon farming that I like to use, which is management principles that minimise greenhouse gas emissions, maximise carbon sequestration in the landscape, while improving the productivity and resilience of agricultural systems. And I think that last little bit is a really important point to make, in that we're not looking to reduce emissions or sequester carbon to the detriment of agricultural productivity or profitability. We're really looking at how these two things can work hand in hand. And so this is the diagram that I was talking about just before, just to make the point that carbon cycling is a natural process that occurs as a result of any land management practices. So it's just about understanding what the carbon cycle is, which, as we can see here, carbon in the form of methane, carbon dioxide or nitrous oxide generally, are the most prevalent ones in South Australian production systems, can be emitted from plants, soils and animals in the agricultural system. They are cycled through the environment, and then carbon emissions can be sequestered in either vegetation or soils. In terms of the co-benefits associated with carbon farming, so if we think of carbon farming as emissions reduction or storing carbon in soils or vegetation. Then some of the co-benefits, there's generally 3 categories that we like to talk about. The first is environmental, and that's things like biodiversity, improved soil quality, improved water quality, and biodiversity is a big one that I think will become more and more prevalent over the next couple of years. It's something that the federal government is talking a lot about in the development of their nature repair markets, and their B+C pilots that they're doing as part of their agricultural stewardship package, which is looking at measuring biodiversity alongside carbon. So looking at how those 2 things go hand in hand in agricultural systems, and what the relationship is between carbon and biodiversity and agricultural productivity and profitability. The next category is social, and that really looks at things like Indigenous community empowerment, First Nations empowerment, increased animal welfare and human capital. And the last one, it's a bit hard to read there in the yellow, is economic. So that is looking at things like improved farm productivity and profitability relating to any carbon farming activities that might be undertaken, diversified revenue streams if that carbon is traded on the carbon market, or that also sort of relates to international and domestic market access, and new skills and career opportunities. So there's sort of a lot of co-benefits that we think about when we're looking at carbon or carbon farming, and these are some of the things that we will start to focus on putting some really strong metrics around us alongside some of our programs that we're doing at the moment, including the carbon farming demonstration pilot, which I'll touch on a little bit later. Again, this slide really reiterates a lot of what Adrian has just said relating to market opportunities. So you probably can't read it, it's a bit small, sorry. This column here just represents the decarbonisation ambitions of some of our major agricultural trading partners. So internationally, what types of commitments some of these countries have. So the United States has a 50 to 52% emissions reduction commitment by 2030. We know that the European Union has a 55% emissions reduction commitment by 2030, and they're also introducing the CBAM to try and regulate some of the emissions associated with their imports. China, the United Kingdom, New Zealand, Indonesia, a lot of our major agricultural trading partners are starting to have implemented these targets, and will start to consider that with their in terms of their imports. The next column over to that far side just describes the decarbonisation ambitions of some of the major food companies that we regularly interact with. So Nestle, General Mills, Unilever, McDonald's, Fonterra, they're all the same ones that Adrian had listed on his slide. They all have decarbonisation commitments as well, at varying time points and to varying degrees, but something that we will need to start considering when we're looking at market access going forward, both domestic and international. In terms of the actual carbon market in Australia, when people talk about the carbon market, it is the Emissions Reduction Fund, which is administered by the federal government. So these Emissions Reduction Fund projects are carbon farming projects that are registered with the federal government, and are measured and monitored over either a 25 or 100-year permanence period, and an Australian carbon credit units, so ACCUs, are accrued in accordance with the amount of carbon that is either sequestered or avoided within those projects. So October 2022, last year, South Australia had 126 projects. So there has actually been quite a big increase in the number of projects that have been registered in South Australia over the last 12 months. Most of those projects, I think 88 off the top of my head, are agricultural projects, and they're largely soil projects. So there's a couple of soil companies in South Australia that are starting to register a fair few projects relating to the application of organic minerals to soils, and how they sequester carbon in the soil. The other major portion of those projects, I think 44, relate to vegetation projects. So that's largely in the rangelands, looking at HAL, human-induced regeneration, which is essentially controlling grazing so that native vegetation can re-establish. Sorry, there we go. Those are the projects I was just talking about. There is actually, that's a map of South Australia, so you can sort of see the distribution of where a lot of those projects are happening, kind of. If you imagine this is South Australia, down here, southeast, west coast, and then the far north up here. So a lot of those soil projects, as we've heard today, there is a strong link between the ability of soils to sequester carbon and rainfall. So we can see that a lot of those projects are sort of happening down there in the southeast where there is slightly higher rainfall. And then those vegetation projects that I was talking about are sort of scattered through the mid-north and into the far north there as well. I won't touch on this too much. We've heard a lot about soils already, and we're going to hear more about soils, and I'm by no means an expert, so I will skip over this one quickly. I will just say that this map has been generated by PIRSA in conjunction with DEW, and it describes what some of the opportunities for soil sequestration might be in South Australia, with the darker areas representing soil that has a higher opportunity to sequester carbon, largely relating to the rainfall in those areas. So you can see Kangaroo Island and largely into the southeast, and places in the Mount Lofty ranges have a higher opportunity for soil carbon sequestration. And one of the things that we will need to realise this opportunity a little bit more is the advanced and ongoing development of technologies, so geospatial monitoring and measuring technologies, for example, which will allow a lot of this measurement of soil carbon to become a bit cheaper and more viable, and also more accurate at the required depths. Just to finish off, I thought I would just go through some of the footprints that we've had done. Well, one particularly on our Tara Field Research Centre, which is largely a sheep enterprise. It might be a little bit hard to see the detail there, but that big blue chunk of the pie is enteric methane production, as we would expect, and that relates or corresponds quite nicely to the graph I had at the start of the presentation, which described the agricultural emissions for South Australia. So 80% of our emissions at Tara Field are enteric methane. The next highest categories they're all 4 and 5%, so it's manure, urine and dung, purchased livestock and fertiliser. So that sort of just goes to demonstrate that there is a big opportunity, especially in these sorts of properties, for livestock emissions to be reduced, and there's a few ways that we can do that, and I'll talk about that in a second. And it also describes the scope 1, 2 and 3 emissions. So in this instance, the scope 1 emissions account for about 90% of the carbon footprint, and that is because of that enteric methane. These scope 2 and scope 3 emissions are negligible, essentially. So in this instance, we know that we can focus on the scope 1 emissions to reduce that footprint. And I will also reiterate the fact that unless we have a good footprint and a good understanding of what that means and how to interpret that, it's really hard to make any decisions about moving towards carbon neutrality or reducing our emissions, because it is, as Adrian has also pointed out, some areas where we might have expected there to be higher emissions, we actually can find that we're not going to get a lot of bang for our buck by focusing on certain areas. So by having a footprint, we can really zero in on where we need to make an investment in terms of emissions reductions or sequestration, if that's the case. So I've just got a definition of the scope 1, 2 and 3 emissions there. We've already been over it, so it's been too long. Scope 1 are on-farm emissions, so in this example it's the enteric methane. Scope 2 is electricity use, and scope 3 is up and downstream emissions. In terms of emissions reduction opportunities for livestock, this top section describes what we can do now. And that's largely around increases in flock and herd productivity and efficiency. So removing cull stock or non-productive stock, decreasing time to turn off, increasing pasture management and pasture utilisation. There are feed additives that are available on the market at the moment, so nitrates, for example, and a product called Agalin, which has been approved in the European Union. And these sorts of, Agalin in particular, was developed to increase the productivity of livestock. And a side benefit of that was that they found that it reduced methane. So the methane reduction is more modest compared to some of the things that we will have heard about in the media, but it is still there. So it is still a reduction, and it's available at the moment, and it increases productivity. So there's a lot of options to think about. Pastures and pasture compounds, there are some pastures that we know about that have antimethanogenic properties. So we're doing a little bit of research at SARDI looking at working out which of the certain pasture compounds might reduce the enteric methane production of livestock. So we're looking at pastures that are widely grown in South Australia anyway, that are used generally as a feed base, and how we can identify some of those components so that we can start to think about that when we're grazing our stock and take that into account when we're looking at emissions reduction. And again, the other side of that is the ability to include this information in a framework. So we're also involved in developing a livestock emissions framework with the federal government. And that will happen alongside a lot of the research that we're doing in terms of methane reduction for livestock. So the ability to actually measure the impact that these changes are having on livestock emissions and then account for that, so that when we are starting to look at using this information to gain market access, then we can verify what's happened and the emissions reductions that have happened alongside that. And there are also opportunities to genetically select animals for reduced methane emissions, and there are some trade-offs associated with that, and it is also a relatively modest methane reduction at the moment. In terms of future opportunities, we've all heard about Asparagopsis, which has been largely touted as having the ability to reduce methane emissions by about 90%. So we're doing a little bit of work on that at the moment. We've got a few research grants more recently to have a look at that. What we know is that 90% is in when Asparagopsis is fed in a short time frame in controlled conditions like in a feedlot. So the challenge will be then what is the opportunity to feed that to animals that are grazing and over longer periods of time. So we're looking at the development of some delivery technologies for delivering some of these feed additives, because we also know that a lot of these additives need to be fed at quite frequent intervals to have that ongoing emissions reduction effect. So we're looking at a few sorts of variables like that. There's a vaccine that is in development in New Zealand, and there are other sorts of wearable or kooky kinds of technologies that are being developed as well to convert methane that's breathed out into other various things. But I've got a 60%, and we'll put lots of question marks next to that. But it is, that's sort of something that is in development as well. So just to finish off, I just thought I would include this slide, which shows the range of feed additives that are actually available and or in development at the moment. So it's certainly not limited to just seaweed. So Asparagopsis is this top one, which shows that there is the greatest chance or greatest opportunity to reduce emissions. But there's a whole range of other additives that are in development and that people are also starting to look at. So I think it's important just to know that we're not putting all our eggs in one basket, and there's lots of opportunities for some of these other additives. This is Agalin, which is what I was talking to you about before. So it has a more modest ability to reduce methane emissions, but it does still reduce methane emissions, and it also improves productivity. So when we start to look at it on a cost benefit sort of analysis, it's much more effective and efficient than some of the seaweeds, which at the moment will cost about $100 per tonne of carbon dioxide abated. There's some other things like biochar, cinnamon, garlic, saponins. So saponins is one of the pasture compounds that I was talking about before, which may have the ability to reduce methane emissions. So there's a lot of research going on in this area. And I will just finish up by telling you quickly about our carbon farming demonstration pilot, which is a grant opportunity that has actually closed now, but we're hoping to have another round of it. And we will be delivering grants of up to $100,000 to commercial carbon farming demonstration projects. So we're looking at projects that are already being implemented or that will be implemented in commercial scenarios in South Australia that can demonstrate carbon farming activities that have the greatest relevance to South Australian production systems. So we're looking to really work quite closely with the successful applicants to get as much data as possible. And as I said, we'll start looking at applying some of those co-benefit metrics. So really putting some figures around what is the productivity increase or the profitability increase, what is the biodiversity that's associated with some of these carbon farming projects. And we're also hoping to overlay some sorts of technologies and engage supply chains in this project as well. So we hope that the projects will be spread across South Australia and will demonstrate a range of activities in a range of industries. And hopefully we'll be announcing the successful applicants in the next couple of weeks. And once we do, then we can start looking at some field days at those sites, and we'll do some case studies and starting to extend that information as much as possible. So I will leave it there. Thank you.